Right, let's take a look at section 14D, which introduces logarithms. Okay, so logarithms can be thought of as an inverse operation. So what do I mean by that? Well, what's the opposite of multiplying by 3? It would be dividing by 3. Adding by 3, take away. Square, square root. To the power of 5, to the 5th root. These are all inverses. So they take you from your output back to your input each time. Okay. If 4 is our input on 3 to the x, well, we would get 3 to the power of 4, we get 81. So what do we call the inverse then? What do we call the idea of going from 81 to 4? Well, the inverse of 3, I guess the exponential of 3, is log base 3 of x. Okay, so these ones here match. These are called logarithms then. So this would be pronounced logarithm base 3 of 81. So you would say log base 3 of 81 is equal to 4. A lot of people sort of struggle with this to begin with. So if somebody is asking you this, the way I would interpret this is, what power of 3 is 81? Yeah, 3 to what power will give you 81? Or what power of 3 is 81? Well, we know it's 4, okay, because we know 3 to the power of 4 is 81. So these are then our equivalent statements. If 81 is 3 to the power of 4, and log 3 of 81 is 4 as well. Don't worry, you'll get a bit of practice with this. It takes a while for the idea to sort of sink in. So log base a of n is equivalent to a to the x equals n. And to start with, you know, something that sometimes helps people is thinking of this as log x, and then this one here is like maybe the other way around as nax. Okay, you can use these to sort of help you remember as you're starting out. So here are some equivalents that we just talked about. What power of 3 is 9? Well, it's the second power. So how can you move between these? Well, there's two ways to understand it, perhaps, and pick whichever one you prefer. So which power of 2 is 8? Well, it's the third power. What's the equivalent way of writing that statement? Well, you could pick out that a is 2, n is 8, and x is 3, and you could kind of write that back in. Or if you prefer, you can sort of like slide the 3 on top of the power of the base and then eliminate the rest. So 2 to the power of 3 is 8. Of course, that makes sense. Okay. You can also think of it as sort of like balancing equations. So if you're in this situation, log base 2 of 8 equals 3, put the 2 to the power of underneath on both sides. If you put these next to each other, because they're inverses, they will just cancel each other out. And you'll have 8 equals, and remember you put the 2 underneath, 8 equals 2 to the power of 3. So there's 1, 2, and if you use the log x, NaX sort of way, I guess there's even 3 methods there to help you get started. So what power of 5 is 25? It's the second power. What power of 3 is 81? It's the fourth power. Pause the video and have a think about the rest of these here. So I'm assuming you've done that. 2 is the fifth power of 32. 10 is the third power of 1,000. What power of 4 is 1? Probably sounds like a slightly stupid question. Well, 4 to the power of what would give you 1? That's another way you could read it. It's 0, isn't it? So in general, log with any base of 1 is equal to 0. That's going to be an important result that's going to come up again and again and again. Okay, it's a great result because it lets us eliminate things sometimes because it's just 0. What power of 4 is 4? It's the first power. You could sort of say, in essence, this is sort of another rule. Log a of a will be equal to 1. Okay. We can use it with fractions as well. So consider changing a half and writing it as 2 to the minus 1. What power of 2 is 2 to the minus 1? Well, it's the minus 1 power, isn't it? The same here. So consider changing this to 3 to the power of something. should be 3 to the power of minus 3. So which power of 3 is a 27th? It's minus 3. Okay, I suppose you could just say which power of 3 is 27, it's the third power, and then just put a minus in front of it as well. Okay, so a couple more examples there. What's the problem with this one then at the end? Try typing it into your calculator. And if you do that, you will get a maths error. It's not going to work. So we cannot do logs of negatives. Okay, you'll get maths error or something on your calculator because the question doesn't make sense. Which power of 4 is minus 1? Which power of 4 is minus 1? Well, you might remember we said it's not possible to get negatives when you're doing powers. So the question doesn't make any sense. Okay, that would be invalid. This is a really important result because we're going to end up with some situations later that will make us use logs of negatives. And when this happens, we need to be able to recognize it and say, no, this is not valid. Okay, so this is an important result that's going to come up again later. On your calculator, these are the 3 different buttons that you may sort of use to express logs. This one here, you can define the base yourself. This one here, this is the same as log where the base is e. It's written as natural log. And this here, if there's no number, it means that there's a 10. Okay, if there's no number, if it just says log, it means that it's a 10. So what power of 3 is 7? Well, it's not. It's above 3, so it's above 1. It's below 9, so it's below 2. So it's somewhere between. Okay, E was like 2.7. So what power of 2.7 is 10? Yeah, this is where these examples are coming from. What power of 2.7 is 2.7? Well, it's 1. These are sort of like inverses, really, and so on and so on. So moving between equivalent forms, you should be getting pretty good at this one now. So remember, you can always go back to log. Well, log x is equal to n equals a to the x is another way that we could say this one as well. So if we want to move between different ways of writing it, you may wish to use this as we've sort of got here. So log base 2 is 16. What power of 2 is 16? It's the 4th power. So we could also write it, if that's equal to 4, we could also write this as 2 to the 4 equals 16. Okay, 3 squared equals 9. So which power of 3 is 9? Well, it's the 2nd power. Okay, so I would have a go at all of these questions on this page to start with, just so you really understand the idea well. Sometimes you'll be able to just write something as a number. So if you spot any of those, just change them to numbers straight away. And a couple more questions. So pause if you're going to have a go at these ones here. A couple more questions here from the book. So some that I thought were quite good as well. And the answers. For F, some of you will have an answer of 0 and 2. But if you put 0 back in, you'll effectively be doing log of 0. Okay, this is not going to be a valid result. So that's why 0 is not possible, but 2 would be a possible answer for F. Okay, that brings us to the end of 14B.